In this video, we're going to look at the volume of a cone and the surface area of a cone. So in this question here, we've been given the slanted height. So the problem is we don't know what the perpendicular height is, h. So we're going to use Pythagoras' theorem here because we've got a right angled triangle. So it's 12.6 squared minus 5.7 squared. We can use our calculator to work this out. So I'm going to my calculator here. So we get 12.6 squared minus 5.7 squared. That gives me 11.23. The volume for a cone is a third pi r squared h. So it's going to be a third pi times 5.7 squared times the height, which is 11.23. Type into my calculator. Third times pi times 5.7 squared times the perpendicular height. So I get 382 to 3 significant figures and it's centimeter cubed. And we say 2, 3 SF. If they asked for the curved surface area, so the curved surface area is pi RL, where L is the slanted height. So in our case, it's pi times 5.7 times 12.6. They could also ask for the total area. So the total area will include the base, which is a circle. So it's pi r squared plus pi RL, the curved surface area. So now we can substitute the values in. So pi times 5.7 squared plus pi times 5.7 times 12.6. Type it straight into our calculator. So pi times 5.7 squared, close brackets, plus pi times 5.7 times 12.6, close brackets. So the 3 significant figures, that's 328 centimeters squared. And that's been rounded correct to 3SF. Here's a question for you to try. You can pause the video and when you're done, I will go through my work solution. So you want to find the volume of a cone. Given your answer as a multiple of pi, it's a non-calculated question. So we can say V equals a third pi r squared times h. So V is a third pi, well it's 8 squared is the radius and the perpendicular height is 6. A third of 6 is 2. So I'm going to write this as pi times 8 squared times 2. That gives me pi times 64 times 2. So the answer is 128 pi centimeter cubed.